Okay, so we're finally on level 4 for writing the equation when we're given the graph of a trig function. So we're going to remind ourselves about how we transform this parent function. So we're going to start with y equals, or f of x equals. We have a sine and an x. At the very end, we are going to add the midline to it. And the midline is simply that line that goes directly in the middle of your waves. The second thing that you're going to have is an A out in front of your sine, and that is the distance from the midline to the maximum or the midline to the minimum, called the amplitude. You can find that in cosine as well. The next thing is if your graphs are reflected or not. So usually when we're talking about sine functions, we have our nice little S shape, and it starts at the y-intercept with a high peak to a low peak. Regular sine function, if it's transformed and reflected, you're going to start at the y-intercept and have a low peak and then a high peak. And that in that case, you're going to make your A negative. Same thing with cosine. Starting at the y-intercept, one cycle, one period is a nice little U shape. If it's reflected upside down, it'll be a nice little hill or an N shape, and we'll make our A negative in that case as well. So negative, negative, right out in front of our A. And then the last thing that we're going to be looking for is a change in the period. So you can see in both of these parent functions, it took from 0 to 2 pi to complete that cycle. Same thing down here, from 0 to 2 pi to complete the cycle. If that is not the case, we are going to put a b value in our equation. And the way that we can find that b value is we're going to do b equals 2 pi and divide it by whatever our period is in our graph. And we can take this same equation and apply it to cosine. So y equals possibly a negative a cosine of b x plus m. So let's do 2 examples of sine and then 2 examples of cosine. So I always like to start these out by finding the midline of my graph. So looking at the dotted graph, I want to find what's directly in the middle of it. My maximum height is at 5, my minimum is at 3, so I have a total distance of 8. So if I want to find the middle, I need to go up or down 4. 1, 2, 3, 4. And we have our midline at y equals positive 1. So then you'll go to your equation, and m, the midline, goes at the very end. So we're going to add 1 to the end. Next thing that we can find is the amplitude. So going from the midline to a maximum, that took 1, 2, 3, 4. You can do the same for going from the midline to a minimum, and it did 1, 2, 3, 4 units again. So A right out in front of sine is 4. Now we're going to look at a period to determine if it is reflected or not. So we can see that we're working with sine, and the regular parent function of sine from the y-intercept is a high peak to a low peak. So we're going to see if that follows for our dotted graph. So starting at the y-intercept, I have a low peak to a high peak. And so that tells me that my graph is reflected upside down. Since it's the opposite of our parent function, this 4 is going to be negative. And I have to find out how long it took to get from this starting y-intercept to one complete cycle. And I can see that right here, I made it back to the midline at 4 pi. So it's not the normal 2 pi period, so I'm going to solve for b. So b equals, I'm going to take 2 pi and divide it by my period of 4 pi. Pi over pi cancels out. We know that 2/4 is really 1/2. So we get 1/2 right there. We'll do the same thing with the second graph. So first I'm going to find my midline. My maximum's at -2, my minimum's at -4. My midline right in the middle is at -3. So I can put -3 at the very end of my equation. I need to find the amplitude going from the midline to the max is 1, going from the midline to the minimum is still 1. So I can put a 1 in front of sine, or I can just leave the a off. We know that, again, for sine, I want this high peak to low peak. So I'm going to trace starting at the y-intercept, and I have low peak to high peak. That tells me that it is upside down. The low peak was first, so I need to make my one negative. And now I want to look at how long it took me to create this period. So going from the y-intercept and going back to the midline for cosine, I can see that it took, tracing up, 8. So to find my b, I'm going to do 2 pi divided by my period, which was 8. And I need to simplify. If I have 2 and 8, they're both divisible by 2. 2 divided by 2 is just 1, so we're left with pi on top. 8 divided by 2 is 4. So my b in my equation is pi over 4. We're going to do 2 examples with cosine now. So I'm going to start the same again where I want to find the midline. My maximum of this one's at -3. My minimum is at -5. So right in the middle, I can see that my midline is at -4. I'm going to put -4 on the end of my equation. You want to find the amplitude now. So going from midline to maximum or midline to minimum, it is just 1 unit. So we can put a 1 out in front. For the typical cosine parent function, that's when we have our nice U shape. So we want to see if the U is upside down or not in our graph. So we're going to start at we're going to start at the y-intercept, and we're going to see that going from the y-intercept to the right to complete one cycle, it is an upside down U. So that alerts me that my 1 out in front is negative. And how long did it take me to complete that U shape going from one minimum to another minimum? I can trace up and see that it took me until pi over 2. So I'm going to find my b by doing my formula 2 pi divided by the period, which was pi over 2. We can rewrite this so that it's a little bit easier to see. 2 pi divided by pi over 2. We know that 2 pi is really 2 pi over 1, and we can work with our fractions division rule. Keep the first fraction, flip the sign to multiplication, flip the second fraction. Pi on top, pi on the bottom, cancels out. We have 2 pi times 2 to give us 4 pi. And then our last example, we're going to find the midline. It's right in between 3 and 5, so we know the midline is 4. Plus 4 on the very end of our equation. For our amplitude, up 1 unit, down 1 unit, they're the same, it's just 1. We know that we're looking for this nice U shape. We want to see if it's upside down or not. So going to the y-intercept, and we can see tracing it is an upside down U. So we are going to make this 1 out in front a negative. Looking for the period, how long did it take me to get this upside down u? Going down, I see that it took me until 15 for a period. So I'm going to do b equals my 2 pi divided by the period, which I found was 15. 2/15 is simplified all the way, so we can't do anymore. We're going to keep it as 2 pi over 15.